Hi, I'm Dave Farley of Continuous Delivery and welcome to this special compilation episode. This episode covers my most important tips for test-driven development. This month we're producing a series of these compilation episodes to help us manage our workflow at Continuous Delivery and to make sure that we can keep producing great content and stay on top of our other projects away from the channel too. But we didn't want to leave you empty-handed, so we thought this would be a good way of keeping you satisfied until we can return with new, fresh content. Before we get to the first clip though, let me thank our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Transfic and Tuple. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. Transfic is a financial technology company applying advanced continuous delivery techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. Tuple builds software to make pair programming easier for people who work remotely. All these companies offer products and services that are extremely well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, click on their links in the description below and do check them out. Now that's out of the way, I hope that you enjoyed this episode and I hope to see you all soon.
Test-driven development is about driving development from test. It's not really about testing as much as a general approach to software development. We organise nearly all of our activities around the need to verify what it is that we create and so test it. It encourages us to take a more iterative approach to design and development as a result, and so work in smaller, safer, better understood steps. We work more incrementally on our design. We create measurably higher quality. I think that you can practice continuous delivery in the absence of test-driven development. But if you do, I am convinced that you will do a worse job. So in this episode, let's explore the what, why, and how of test-driven development. In 2014, a study of nearly 200 production failures in software systems of all different kinds, researchers found that most problems were caused by simple programming mistakes. The kinds of mistakes that programmers make in every software system, in every language, whatever your tools or your approach to software development, we software developers make the same kinds of mistakes over and over again. Off by one errors, conditionals the wrong way round in conditional statements, scoping problems with variables, all of these things, if you've done any programming at all, I am sure that these ideas will be familiar to you. And these are at the root of the vast majority of production failures. To quote the report that they produced, they found 58% of these mistakes are trivial and can be exposed by statement coverage testing. If we simply checked that our code did what we thought it did, we'd eliminate nearly 60% of production defects. That's a huge step forwards. Actually, if you take this idea really seriously and start applying test-driven development in its broadest sense, in the continuous delivery sense that I tend to talk about, the empirical data is even stronger than that. Paddy Power reported that when they made the switch from a more traditional development approach to applying the techniques of continuous delivery, they saw a greater than 90% drop in the number of defects in production. This kind of value is hard to ignore. So what is it about test-driven development that can deliver this impact? Code is weird, unusual stuff. It's complex, expressive, and fragile. There's not much in human experience that's really like that. One thing that comes close is, strangely enough, accounting. It's not as complex as software, but it shares that unusual fragility that we see in software. In both cases, one tiny error can invalidate the result. It's rather like if when you wrote a book, a single spelling mistake made the book unreadable. Adding up lots of numbers is error prone, and so humans make mistakes all of the time. Accountants found a solution to this problem. Depending on what sources you look at, it dates back to either the Romans or Genoa in 1340. They invented double entry bookkeeping. In double entry accounting system, at least 2 accounting entries are required to record each financial transaction. That's the description of double entry bookkeeping. This is an error detection protocol invented all of those hundreds of years ago to help accountants spot when they made mistakes. What they do is that accountants record each transaction twice from different perspectives, and if the results don't match, then there's a mistake somewhere and they go in search of the mistake. In code, we have the same problem. All of us developers make mistakes in our code all of the time. Our tools catch some kinds of mistakes. Little red squiggly lines in our IDEs are great feedback, fast and efficient. But there are some kinds of problems that they won't catch. It only takes us so far. What would give us an independent path verification that our coding actions matched our intent? Test-driven development. TDD allows us to express our intent in the form of a test, a mini specification for the behavior that we intend in our code. We can check that mini specification by executing it before we've written the behavior and checking that it fails. And seeing if it fails, we know now that our test is actually testing something useful. Next, we're going to write some code to fulfill that intent. Just enough code to get back to a stable passing state with our failing specification of the behavior. The bare minimum to meet that mini specification. We run our specification, our test, again to confirm that it passes now. Now we're in a stable state. All of our specifications, tests are passing. So now we can do some more creative work. We can take more chances because we've got the defense of these passing specifications or tests. To make our test and our code more expressive, we can start changing it and modifying it, more general, more readable, simpler. The test describes this desirable behavior of our code one way. The code describes it another. Here is our independent path verification. Here is our version of double entry bookkeeping. A good way to capture all of that little flow is often used to describe test-driven development. It's the mantra red, green, refactor. Red, we're going to write a test and see it fail, run it, and that's the red condition. Green, we're going to make the code pass with the minimum change. Refactor, we're going to tidy them up and make them beautiful and elegant. And that's the last stage in the process. This is a good way to think about test-driven development and a good discipline to adopt in its practice. This is a very different and much more powerful practice than simple unit testing. Unit testing is, as the name suggests, all about testing. Test-driven development, as the name doesn't suggest, is all about design. As a side effect, it creates better tests than unit testing. So what does the phrase TDD is all about design really mean? Let's think about design and why we care about it for a moment. What would we consider to be quality in code? I think the first and obvious thing that we would be looking for is that it works. It does something that is helpful in some way. As programmers that need to work in the code, we'd also like it to be easy to read, testable so that we can check that it does indeed work, easy to maintain, easy to change in the future. Simple and efficient as possible. We'd like all of those things. What sorts of technical properties of code deliver those values? And I think there's a relatively short list. Good code, in the sense that we've described, is modular. It's broken up into smaller pieces that are each easier to understand and deal with. It's loosely coupled. Those pieces are not tightly bound together and have a little bit of freedom to change independently of one another. It has high cohesion. The bits of behavior that are closely related to one another are physically close together in the code. Good code has good separation of concerns. Each piece Each cohesive unit of the code is focused on trying to achieve one task, one outcome. When we blur together too many different responsibilities in code, that is inherently poorer code than if we don't do that. Good code exhibits information hiding. It allows us to deal with another part of the code without worrying too much about the detail of what's going on behind those divisions. If we follow test-driven development as a discipline, we don't write a line of code until we have a failing test that demands that line of code from us. Now, if you're always going to start with a test, you'd have to be rather dumb to make your life harder by writing nasty, complicated tests. We're smart people. We're going to make our lives easier. That's part of the benefit of computers. We can use them as tools to make things easy for us. So we're going to try and find a way to write tests that are easy. They're going to capture our ideas simply. So we're going to try and keep the tests simple. They should be easy to write. In order to be able to achieve that, what you are doing is you're trying to create testable code. That's going to make the test easier to create. Testable code looks different to code that wasn't written with it in mind. Here's a really simple example. Let's imagine for a moment that we have a car. Here's a simple class, a car, and this car has an engine, a petrol engine inside. We've got a start method on our car, which is going to put the car into neutral. It's going to apply the brakes to make sure that we don't roll away, and then it's going to call start on the engine. Let's imagine that we wanted to try and write a test for that. We could create our car, we could tell the car to start, and how do we tell whether the engine started? Well, we can't. We can't do that because we don't really have access to the engine. The engine's just a component of the car hidden away somewhere. We could change our design to try and make it more testable. So here's a better car, and this better car has a fake engine, which we're going to inject into it. We're going to start the car again, and then we're going to make an assertion that the engine started successfully. That's our fake engine, remember. Our better car looks a bit like this. We can inject an engine into the car and it just holds onto that reference. Notice how decoupled the car has immediately become with respect to the engine. It doesn't know anything about the engine. So us supplying a fake engine is perfectly reasonable. Now, here's a simple picture of the fake engine. It's just going to do start, and it's just going to maintain the state of this. In reality, we probably wouldn't create a class like this. We'd use a mocking library or something like this in test-driven development. But I just wanted to demonstrate the principle. We're just going to record the fact that the engine was started. That gives us the ability to immediately test the code. This is testable code. Think now what that means for the design. My better car works fine with a petrol engine. We've tested it with a fake engine, but if we injected a petrol engine, as long as it fulfilled the contract of being able to start, being startable, it's going to work. But equally, I could have all of the same car, except I could change the engine. I could have an electric engine instead. Or if I was slightly crazy, I could create a car with a jet engine. All of those things are equally open to me with my better car. The code that I created is more flexible, and it's more flexible as a result of working to try and make it more testable. Test-driven development is not a silver bullet. It's not going to automatically turn you into the world's greatest programmer. My observation, though, is that it is something of a talent amplifier. It's not going to make a bad programmer great, but it will make a bad programmer better. And it will make a great programmer greater. And so whatever your level of skill or experience, test-driven development will help you to do a better job, in my opinion. Test-driven development doesn't stop at the commit stage unit tests. I consider automated testing to be one of the foundational cornerstones of the continuous delivery approach. Continuous delivery makes little sense to me without the idea of continuous automated testing at its heart. So, where do you begin? As I said, test-driven development is not just about unit testing. And I have several other episodes on the channel that describe other aspects of test-driven development: acceptance testing, BDD, executable specifications, as well as the more fine-grained detail of test-driven development style unit testing. But the starting point is really that low-level, fine-grained exercise of test-driven development. To get started with this, I recommend that you look at something called coding katas. Coding katas are simple programming exercises that allow you to kind of rehearse, practice your discipline. Pick a coding kata, something really simple, something like FizzBuzz or adding fractions. Just pick a really simple little exercise and perform that exercise repeatedly over a period of weeks. My recommendation is that you allocate half an hour every day for at least 2 weeks and spend half an hour every day performing one of these coding katas that you like. Use test-driven development and really stick to the rules. Don't write a line of code that isn't demanded of you by a test. So always start from the test. At the point at which you write your test, make the test force you to create the classes that you need. Make it force you to create the methods you need, and so on and so on. Follow that discipline. If you follow my advice and do this for half an hour every day, just on these simple exercises, that will start to demonstrate to you some of the power and in this technique. The problem with coding katas is that they are not as complex as real code, but the advantage of coding katas is they're not as complex as real code, so you can really practice the exercises. It's a bit like playing scales if you're a musician. So I do recommend that as an approach to you. If you want to find a good source for coding katas, there's a lovely website called CyberDojo, which provides you with everything that you need to practice test-driven development in a variety of different languages, and gives you a whole raft of coding katas to choose from as little exercises that you can perform. I think that test-driven development is one of the few practices in our discipline that really functions as genuine engineering, by which I mean a reliable, repeatable technique that makes the code that we create better. I can't think of anything else other than saying be smarter, which is not very helpful, that really works. I think that test-driven development is one of the more important advances in software development that's happened during the course of my career, but it hasn't taken off in the way that I expected to when I first learnt about it. It is widely practiced in all sorts of industries with all sorts of different technologies. But it's not the starting point for every team, which I think it should be. I wish that more teams practiced it and saw its benefits. Perhaps one of the reasons that it hasn't become ubiquitous is that it's easy to make some common mistakes that mean it doesn't work too well. So I thought that it may be interesting to look at some of these common mistakes. This isn't poking fun at people for getting it wrong. We all get it wrong sometimes. I would argue that being able to spot early in the development process when we're heading off course, when we're beginning to get things wrong, is one of the main benefits of test-driven development and of good software engineering in general. If you'd like to learn more about engineering for software, I have some training courses that may be of some help. I also have a new book out called Continuous Delivery Pipelines, which is a practical guide to how to get started or how to improve your deployment pipelines. If you want great feedback from your test-driven development, there is no better way to getting it than from an effective deployment pipeline. Links to all of these things in the description below. Test-driven development gives, or at least should give us, feedback on the quality of our design. More than any other practice that I know, it does this. This is the reason that I value it quite so highly. When test-driven development works, we establish a fast, efficient feedback loop that gives us a valuable insight into our design. If our tests are difficult to write, that isn't a problem with the test. It's telling us something important about our design. And if we listen for these signals, we can design better quality code as a result. Not just in the simplistic sense that we've tested it and so know that it works, but in the deeper, more durable, technical sense of more modular, more cohesive code with better separation of concerns and appropriate levels of coupling that allow us to maintain and evolve this code over long periods of time. So what are some of the signals to watch out for? What does it look like when test-driven development is starting to go wrong? Here are 5 common anti-patterns. Before I begin, let me give a shout out to James Carr's blog post on test-driven development anti-patterns, which I use as a jumping off point for this video. The first of these anti-patterns is the liar. The liar passes all tests, but doesn't actually assert anything useful. The cause for this common anti-pattern is it's often seen in teams that are trying to chase test coverage, where somebody higher up in the hierarchy has mandated some level of coverage, and so we build tests that don't actually test anything. I once worked for an organisation that set a target of 80% test coverage and incentivized people with bonuses if they hit the target. Guess what? They hit the target and their tests didn't assert anything at all. So people were paying people to write tests that didn't provide any value. This is commonly seen in teams that don't practice test first, red-green refactor test-driven development. The problem with this is it gives you the illusion of coverage. You think that you are safe when you are not. It's also obviously waste. We are paying people to create tests that have no value whatsoever. The correction here is delete the tests with no coverage or possibly add some assertions. Practice test first, and it's hard to do this. If we're doing test-driven development properly, we're going to write a test, run it and see it fail. In order to be able for it to fail, we have to have an assertion of some kind. And when we do that at the point at which we're going to write our test, before we have any code, we're going to predict the way in which it's going to fail. So it needs to fail in a specific way that meets our goals. So it's very, very hard to fall into this trap if we follow test first, test-driven development. The next in the list is excessive setup. This is an incredibly common pattern in automated tests in general, and unit tests nominally referred to as test-driven development in particular. This is a test that requires a lot of work to get the code ready to test. The cause for this is often the result of writing the code before you wrote the test. You weren't thinking of the design of your code to make it testable at the point at which you wrote the test. You were just thinking about how to solve the problem that the code is focused on. This makes it hard to test. It indicates a poor separation of concern in the code under test. So if we see this signal, we should be starting to think about our design. The problem with this is that the test and the code become very highly coupled and so very fragile. It's very easy that over time, projects that apply this kind of approach will gradually, slowly grind to a halt. It's almost impossible to make any move without breaking a test every time you change the code. And that's clearly not a pleasant way to work. It's inflexible. It's because the tests are so tightly coupled to the code under test. And it's difficult to understand what the test is trying to achieve because, again, it is largely focused on being so tightly coupled to the system under test that it's really just testing the implementation rather than the desirable behavior of the system. So it's hard to understand and hard to maintain as a result. The correction for this, when you see this signal, is to start improving the abstraction in the system under test. Start carving the system up into smaller, more modular pieces that are more focused on achieving some desirable outcome that is testable. Improve the separation of concerns. Think about teasing these things apart. Think about one class, one thing, one method, one thing, and test-driven development strongly assists in this kind of thinking. Practicing test first, writing the test before you write the code, forces you to simplify the setup, because you'd have to be kind of insane to write a test before you'd written any code that required you to do complex setup. You're going to try and make your life easy by writing simpler code. Here's an example of some excessive setup. Here's a test from a real-world project. In this case, it's evaluating a behavior of a build management system, in this case Jenkins. For this test, it's starting up Jenkins, all of it. It's configuring an environment in which I can run Jenkins, starting it up, and then the test is asserting that we don't have the word localhost in the URL for the test. Think about the cost of that test, creating it, writing it, running it, to be able to assert that the word localhost doesn't occur in the URL. This is waste. You would never in a million years write a test like this before you'd written the code. This is clearly a test that was written after the fact. If I was approaching this from a test-driven development approach, I'd probably write something more like this. I'd write a test that asserted that my URL didn't have localhost in it, and then I would write some code that fulfilled the needs of that test and gave me the result that I was looking for. This is simple. I can run this as a unit test rather than having to start up the whole application to test a string, whether a string contains a word. Third in my list of anti-patterns, the giant. A test that is comprised of many, many lines of code and makes multiple assertions. The causes of this is almost inevitably, this is caused by writing the test after you wrote the code once again. It's not the outcome of test-driven development very often. These are often implemented consciously as kind of component level tests intended to test some bigger chunks of software. But nevertheless, it's still problematic. The problem is that the intent in these tests is very hard to determine. It doesn't really tell you what's going on. We tend to have built these tests and grown them organically, iteratively, just as a kind of convenience, rather than a focused evaluation of some specific behavior that we're interested in. These sorts of tests don't really document the behavior of the system that they're testing in any sensible, useful way. They tend to be, once again, highly coupled to the system that they are testing because they're written after the fact. And so they tend to be very fragile. Again, the outcome of this is over time, projects that apply this kind of approach to automated testing tend to grind to a halt. They get to a point where they can't move forwards without they can't change the code without invalidating the test. They can't change the test without invalidating the code, and they're just stuck. The correction for this is to decompose the test into multiple test cases that are focused on testing and asserting one thing. Make one assertion per test. Prefer tests that look like this rather than this. Here's an example. Again, from the wild. This is a real test in a real project. And in this test, you can see this doesn't really look like the second version of pattern that I recommend, more like the first. It's big and complicated. In this single test case, there are 9 different assertions. If this test fails on the 7th or 8th assertion, what does that mean? Does that mean that's what went wrong? Or does that mean something went wrong earlier on, but this is just a side effect of that earlier failure? We don't know. Figuring out how that test went wrong is going to be difficult and complex and involve quite a lot of work to uncover what's really happening. If we get to the really simple picture of one assertion per test, the test is effectively shouting at us what went wrong very clearly, very precisely when it fails. The fourth in my list is the mockery. And the name of this is kind of mildly amusing, and this pattern is kind of mildly amusing too, or anti-pattern, I should say. This is a test case that uses so many mocks or stubs that the system under test is not tested at all. In fact, in some cases, there is no system under test, there are only mocks. The causes for this are again down to the problems of excessive setup. See the excessive setup pattern earlier on. If we are struggling to be able to establish our system in order to be able to test it, then that tends to, we're so focused on trying to achieve that we tend to lose the focus on the target of what it is that we're really trying to achieve. This is down to, once again, poor coupling in the system under test, testing by rote, developers working on building tests just because somebody else told them to do it rather than seeing it as a valuable tool to assist their own work. The problems here are that it doesn't actually do anything at all. We write a test that does nothing at all. I suppose that we could say that the test is not readable, it's poor as documentation of the intent, it's highly coupled and so very fragile. Over time, again, the projects tend to grind to a halt as a result of this kind of overcoupling. It's difficult to understand and maintain what's going on. But, I repeat, it doesn't do anything at all. Here's a mockery example. Here's a test case. It looks reasonable, but here's the setup for this test case. And in this, if we look carefully at this, both the car and the engine are mocked out, and those are the only things that we're testing. So basically, all we have here in terms of production code are two interfaces with no implementation, and that's what the test then evaluates. This is just waste. It's just coupling for no reason. This is a waste of time, a waste of effort, a waste of CPU cycles when we run it. The correction for these kinds of problems is to review the design of the system under test. Start thinking about testing as a tool to achieve some outcome rather than a chore that you're forced to just implement because somebody else told you to do it. Improve the abstraction and the separation of concerns in your design is going to reduce that horrible setup overhead that tends to lure you into these kinds of ridiculous situations. Practice test-first development because, again, that's going to tend to keep you sane. You're not going to write those complex setups, those excessive setups, if you're writing the test first, because you're going to very quickly say, why am I doing all of this work just to test this thing? Maybe think a bit more carefully about what it is that you are trying to test. Focus on the behavior that you desire from your software rather than the technical implementation of it. The last in my list for today is the inspector. This is a test case that violates encapsulation in order to make assertions. The causes of this it's nearly always the result of writing the code before you wrote the test. Striving for 100% test coverage is also a common cause of this kind of failure. I think that test coverage is a very poor metric for success. Teams that practice effective test-driven development do get great test coverage, but using test coverage as a target tends to bring out the wrong behaviors in teams if they're not focused on what the real value to them is. And the real value to them is that test-driven development makes their designs better and their work easier. It's not about coverage, it's about test-driven development as a tool to evolve better designs. The other cause for this kind of failure is no or improper use of dependency injection can also result in this kind of failure. Tight coupling between tests and the system under test is another one of these of the problems that kind of comes with this. These systems tend to be so highly coupled and so very fragile that over time, once again, projects tend to slow down and grind to a halt. I've repeated that phrase several times in this video. That's because that's one of the common objections to test-driven development. And from my perspective, what I've seen in my career and my practice of test-driven development is that that's a symptom of many of these cases, and often not really a failure of test-driven development. It's a problem of after-the-fact unit testing, which is a very different thing. The correction to this is to never compromise the encapsulation of your system to support testing. Instead, design code that is testable from the outset. Here's another example. This is an example of again, taken from a real code base, a real open source code base. And there's a bunch of stuff here. We're testing some stuff. We're looking at some various attributes of this code. It's a fairly unpleasant test, as we can see. There's a whole bunch of complicated setup to get this into a state where we can do some work. And then one of the assertions is this. And this, as far as I could find searching the code base, this method does not exist anywhere in the production code. The only place where this method is ever used is here in this test. This method was added to the code in order to support this test. Again, I think that you wouldn't do that if you were writing the test first. So I think this is clearly a test that was written afterwards. I think that you wouldn't do that if you were trying to avoid coupling with the code on the test. You certainly wouldn't do this if you were focusing on trying to assert the behavior of the code that you were testing. So, in order to cure this kind of problem, we need to improve the abstraction in the system under test to make our system more testable, improve the separation of concerns in the system under test so that the components of the system are more independently testable of one another in the context of development and test-driven development. We can use mocks or stubs to provide measurement points where we can gather information that tell us about what's happening in the code. That is much preferred to breaking encapsulation and digging in and looking at internal representations or internal private state. Try to write tests that test the desirable behavior of the code rather than its implementation. As I said, these anti-patterns aren't just failures. These are the tools that we can use to highlight the direction that our design is taking.
I was first exposed to extreme programming, the approach that introduced the world to the rediscovered idea of test-driven development, as well as its associated practices like continuous integration and pair programming, in around 1997. That was very soon after Kent Beck published his book Extreme Programming Explained. I had already tried a form of continuous integration, though it wasn't called that then, a few years before when we created a rolling continuous build for one of the projects that I worked on, and that had been very successful for us. On that early 90s project, we had a handful of smoke tests to validate the basic core functions of the system, but it certainly wasn't test-driven development. When my enthusiastic young teammate said we should do extreme programming a bit later, we all laughed and dismissed the idea because of the silly name largely, even though we were already taking automated testing pretty seriously on that project and running a continuous integration and build process. The testing though was more of the whole system integration style testing. The moment when the TDD light bulb went off over my head first started when I saw JUnit, which made unit testing so much simpler and so much more obvious about what we should be focusing on than anything that I had seen or done before. I thought at the time, this looks like a fantastic idea, and we certainly improved our testing on that project by adopting JUnit, but even so, the real lesson of test-driven development still didn't really land for me properly. I treated it rather as a tool in my toolbox to occasionally pull out when I thought it was useful, rather than as a guiding principle for how I would organise my work, which is much closer to what it is today. Like everyone else, I didn't really get the prime directive of test-driven development, write the test first. It just seemed so unnatural, and it just made the testing that I already valued much more difficult. A few years later though, I joined a consultancy called ThoughtWorks, who were very big proponents of test-driven development and extreme programming. Here I worked with people that really understood TDD, a lot better than me, and I learned from them. This was the time when I really got it and thought, this is amazing, in the future all code will be built this way. Again, I was still wrong. I tell you this story because I think it points out two big barriers to the adoption of test-driven development quite effectively. The first is that it's easy to confuse unit testing with test-driven development. Now I see them as distinctly different things, but in my experience everyone mistakes unit testing as the important bit at first, but I'd argue that in reality it's the other way around. Everyone starts out thinking, okay, I get it, it's all about having loads of unit tests and amazingly high levels of test coverage. But that isn't the goal at all. That's a side effect, not the goal. The real target is to be able to build better software more easily, which is something that you get from test-driven development, but usually don't from unit testing alone. The other thing that my story tells us is that it is extremely helpful to work on a team that already gets it. My previous team, who first attempted extreme programming, were a very skilled, very talented group of developers, but we all missed the real value of test-driven development, and so of extreme programming really. Working with people who already get TDD is by far the best way to learn it. In fact, I can't think of anyone that I know of that's been through that experience who didn't afterwards prefer test-driven development as their approach. My impression is that the people who dislike it have never really tried the real thing. That sounds like a horribly dismissive thing to say, and it's not really very helpful in trying to convince people, for sure. But I don't really mean to be dismissive, but as I have said before, in my experience, all of the things that people complain about in test-driven development aren't outcomes of TDD at all. They're outcomes of poor unit testing. I explain this in more detail in this video. I published a question on Twitter a while ago and got a lot of responses. My colleague Bernard recently published a LinkedIn post analysing the responses we got, and he found 10 categories of challenge to test-driven development adoption that people generally responded with. Here I'm going to go through those 10 and talk a little bit about each. The first one is the learning curve. This is certainly true. No one is born with the innate ability to write code, and no one is born being able to write code with test-driven development either. This is a skill. It takes time to learn, but then so is coding. I think that the real skill barrier though in TDD is less to do with TDD itself and much more about what it exposes us to so clearly, the poor quality of our design choices. I think that I can teach you the basics of test-driven development in a few days, but learning to be good at design is the kind of skill that will take you a lifetime to acquire. And more than anything else that I know of, test-driven development presents you with the costs of your design choices immediately. This is one reason that I value it so highly, but I think it's one of the reasons that makes it more difficult to adopt. In that sense, yes, test-driven development is difficult to learn. But the important point here is that what you are learning is a skill that is absolutely foundational to what it is that we do for a living, design. So maybe that's worth a bit of investment in time and effort to increase your skills in this vital area. Which takes us to the next in the list, the investment in time. A common thread in the responses was that test-driven development takes much more time than working without. And again, there may be some degree of truth here, but once again, I would argue that this is something of a misinterpretation of what's really going on. There may be a little bit more typing involved, sure, because we've got to create tests. But if that is your limiting factor in software development, typing, I think that you're probably doing it wrong. We need to optimize for thinking, not typing. If it takes me longer to come up with a better, more flexible, more readable design, I think it's worth it, particularly when you factor in what really matters in terms of the time that we spend, the overall cost of living with the code that we wrote. If test-driven development allows me to write code with fewer bugs and makes my code easier to change, then that is a good big bargain in my opinion. Third in the list is the lack of education in test-driven development. I guess this is fair. I said already the best way to learn test-driven development is from people who already know it, and ideally in your own code base, so working alongside people that are already practicing test-driven development. But there's a shortage of people with these skills, and so that's a difficult way to learn. In the absence of having someone to show you how, Do check out my free test-driven development tutorial that's meant to help to get you started. There's a link to that in the description below too. Fourth on the list are cultural factors. There is a lot of resistance to trying new things, and test-driven development raises a lot of objections, usually from people who have never tried it. So this is certainly a barrier. My advice is to try it anyway. See what you make of it for yourself, but you will need to practice a bit. You can't tell if you like test-driven development or not in an hour or two. It takes longer than that to get it for most people. My advice is to commit to completing a simple coding kata of some kind for 30 minutes every day for 2 weeks. After that, you'll have a much better idea of whether there is something in it or not. Check out the tutorial for examples of that. Code design and evolution is fifth on the list. I wonder if this objection, though, is one of those symptoms of confusing unit testing after the code with test-driven development. The huge win in test-driven development is when you understand what it is that you're meant to be testing. The goal is to assert what you want your code to do, not how it does it. This is much more natural and easier to do if we write the test before we write the code than it is if we add the tests later. I find test-driven development makes my code much easier to explore with, and I'd say it enhances my ability to design and evolve my solution rather than hampers it. Next on the list are maintenance challenges. There is some extra maintenance. We're going to have to maintain the tests as well as the code, but the amount is largely down once again to the quality of your design, and that is part of the trick and the challenge that test-driven development offers to you. As I said earlier, test-driven development gives us the earliest opportunity to get feedback on our design choices. If we listen and respond to that feedback, we change our code in ways that makes it better. In particular, makes it more modular and cohesive with better separation of concerns, better abstraction between the parts of the code, and looser coupling all around. All of these things make the code both more testable and considerably easier to change and so maintain. So although you may now need to change tests as well as the code when maintaining everything, in my experience this is less than changing the worst code that I probably would have written without the tests. As ever, writing tests first is the key here. The tests can't drive better design choices if you don't write them until after you've made your design choices. Next on the list are the perceived benefits versus short-term costs. It's impossible to talk about other people's perceptions sensibly, but my impression is that people who think that this tend to undervalue the benefits that we get from TDD and overvalue the short-term costs. The most efficient, effective teams that I've ever seen, let alone been part of, have all practiced test-driven development. You have to remember to factor in the saving in time, effort and money of not needing to fix bugs that don't exist in the code anymore. This is hard to evaluate, but the state of DevOps data, which measures continuous delivery practices in general, but not TDD specifically, says that teams that score well on stability and throughput spend 44% more of their time on new features than teams that don't. I guess that there's a fairly high correlation between people doing well with continuous delivery and people practicing test-driven development. If I'm honest, I think that this is more of an excuse and a mistake by people who don't really want to do test-driven development. They think that they will spend more time writing tests and less time on the stuff that they like doing, designing the solution, when in reality the reverse is true. The tests are, after all, part of the design process. Next in the list are misconceptions and misinterpretations. This is less of an objection to test-driven development and more an observation of the reasons why others reject it, which is, given the original question, fair. Yes, there are lots of misconceptions and misinterpretations of what TDD is and what it's like to practice. So I think that is a barrier. The next on the list, practicality in specific scenarios. There are certainly some times when test-driven development is harder than others to apply. Most of those have to do with I/O of one form or another and maybe concurrency. But in reality, this mostly once again is a matter of design choice. When you buy into test-driven development, you tend to change to make your designs easier to test. And I would argue that the choices that you need to make to achieve that are nearly always to the benefit of the design and quality of the code. There isn't a specific technology nor a type of software that I've come across that isn't amenable to test-driven development in my experience. Yes, you can build UIs. Yes, you can build embedded systems. Yes, you can build high-performance systems. Yes, you can build safety-critical systems. All of these situations work. Last in the list surprised me when I saw it, the fear of job security. This was the most surprising entry on the list from my point of view, and one that I have never seen personally. Apparently, some people have met others who were scared that if they wrote tests for their code, they would make their code easier for others to change. And so that made them scared of losing their jobs. That's a pretty sad state of affairs, and I'm not sure how to react to it. My working assumption is that if you write better code, then you'd hope that that would at some level be recognised as a good thing, and so make your employment more secure, not less. I guess that this is a kind of backhanded compliment to test-driven development. It makes my code so easy to change that my job's at risk. I don't really have any advice to people working in such dysfunctional organisations other than to say, keep an eye out for better places to work. It's been my experience that good software developers are hard to find. So while not doubting that there are some employers that are so bad that this story may be true, I can't really imagine that making my code worse to secure my job is likely to be a good long-term strategy. Please do check out Bernard's article. There's a link in the description to that below too. Thank you for watching. I know that this was a little different to what you normally expect from us here, but I hope too that you enjoyed it all the same. Please do subscribe and like if you haven't already, and if you did enjoy the content today. Also, you might want to consider joining our Patreon members. Our Patreon members get lots of exclusive perks. There's also a lot of useful information on our training site, including detailed free tutorials as well as paid-for training in modern software engineering techniques. I hope to see you here next time. Bye-bye.